Now I'm going to show you some simple use of check constraints. I'm using the price table as an example, and first of all I've actually commented this out. I'm going to comment these out just so you can see the various ways of doing things, and I think I commented the wrong thing out there. And back to here, let's go and uncomment this. This is a comment in SQL+. It's a double dash. It will comment out the current line. If you want to comment out multiple lines in SQL+ or in SQL Oracle, you do this and it will comment out anything between those lines. Obviously that's going to cause me an error, so I'm going to do that. And so here all I've done is I've said add a check constraint that says, okay, well the field is a float, it's nullable. Also I've added floats in places where they're relevant. A float variable, as you recall, is a floating decimal point. The decimal point can be anywhere, generally a large number. So here what I've done is I've said float null check price greater than 0. So what happens if you come into this table and you try to add a row and the price is less than or equal to 0, it'll give you an error. It won't add the row, it'll roll it back and chuck it out. So here's a perfect way to demonstrate something. If we go back to the data model quickly, let's go and find the data model quickly. Let's open it up. The price table actually says one too many. So tickets are actually dependent on the price. So because of the constraints, the foreign key and primary key constraint settings between the price and the ticket table, here we say foreign key ticket price foreign key references price. If I try to drop the price table right at this point, let's go to here, drop table price. It's going to tell me I can't do that because there's a unique primary key reference in another table. What that means is you either have to go and disable this foreign key that links ticket to price, as in you have to disable this relationship here, or you have to drop the ticket table first. That's the easy way to do it. I don't have any data in these tables. It's not critical. It's just a test database. Drop table ticket, drop table price. So you see the referential integrity in action. As far as the table metadata objects are concerned, the data itself behaves the same way in that you wouldn't be able to delete a price entry if it had any ticket entry rows by individual rows. In other words, delete the row as opposed to drop the entire table. So this has been dropped. I can now go and create this table, and it tells me I have a duplicate column name because I have, oh yes, this was the original. I commented it out. So what I'm going to do is just going to show you that it actually works. All right. The other thing I have in this progressive setup here, or definition, is I take this definition out here, I put it back as this is an inline constraint check. Right. Now I'm going to take that out of the inline definition for the on against the column. I'm going to do it out of line. First of all, I'm going to create this same constraint out of line check price greater than 0, and then I'm going to actually add another column which I've got here where I've added a default value. So if we try to push a null into discount, it will set it to 15 automatically, as in a discount of 15%. So what I'm actually doing here is check price 2. I'm saying if the price times the discount is greater than 10, as in a percentage, chances are this should actually be divided by 100, because generally discounts are percentages. It's immaterial exactly what it is. All I'm trying to show you here is you can have an expression in here and you can access more than a single column. In fact, check constraints can get a lot more complicated than this. However, this type of complexity starts to get into the realm of number crunching. And as a data modeler, what I prefer to do is to not put number crunching processing inside the database. Many data modelers might like to do that. I don't think it's the best idea, because a piece of software that's application oriented like Java or C It's much more capable of doing this type of processing. I generally do not use check constraints in any data models I create, whether they're for books or for contract jobs, because they're better in the application. The application's better geared to handling number crunching. A database is good at processing data, passing it in and out and doing certain things to it, but not complex checks like that. So I can drop the price table again, and I create it with the extra constraints, and in theory I should go and create the ticket table again, because it doesn't exist because I dropped it. And now I can go once again into SQL Developer, and I don't know if this actually will retrieve it. It should, it may not. Yeah, it does. It's got the discount column. And I'm going to go to the constraints, and we see now we have named check constraints with the search condition, whatever you want to call it. It's not exactly a search condition, and we still have the same primary key index. As the check constraints are actually very simple, but I'd be very careful using them from the modeling perspective. They're better off placed in the applications.